In our last video, we got the number guessing game to work, random numbers to work. Basic program works. It is missing a high-low comparison for a hint, which I think is a good thing to do with 256 possible numbers. And let's just look over how it's running. Currently, it waits for you to hit a key so that it can generate a random number based on a timer. The result should be D1. We're leaving that hint in for the moment. It's a little more than a hint, it's the answer. But let's try the various numbers. So 00 does 00, FF does FF, AF does AF, uppercase AF does AF, B0, 0B. So it looks like we fixed the functions that read the string that comes in and does the right thing with turning it into hex, and we can go ahead and remove that debug code out of the mainstream here. Let's go ahead and do that first. And that was right after here. And the print long, we'll just get rid of that print long for the moment. Leave it in case we have to go back, but I think we've killed that bug pretty effectively. Save it. And do the same routine. Processing, update memory initialization file. Compile. And we'll get ready to upload the program. Uploading the program. And any key to start. So we'll hit a key. Still has the hint. Oh, and it's still printing back the number that we got. So what did I do wrong here? I'm printing out a long. Printing out a long here too. I don't think I need that long any longer. Get rid of that one and get rid of that one. And let's try again. Or did I forget to assemble? I might have forgot to assemble. That's probably what I did wrong. Yeah, that's the random number. I do want to print that. I think I just forgot to assemble. So always assemble. Otherwise, you'll get back what you got the previous time. So we got that compiled or assembled. And we can do update memory. Start the compiler going, the FPGA. Upload it, and hit a key to continue to generate the random number. And we have AD 99. Looks like we are not printing it to the screen anymore. That's good. A3. What AD? I wonder if it's AD. Wow, it is AD. Okay, let's go do some more enhancements to the program. The key enhancement that we will want to do is to do the too high and too low string. So we need to do a comparison for that. One of the other things I tossed in here was a couple of stars, 3 stars before and 3 stars after the bad number error to make it more obvious that there was a bad number. I had hints earlier and I just missed them. So how do we get to too high and too low? Well, we're going to do it down here where we're comparing R8 and R15, and instead of just equal for guessing it, we'll add another branch of less than to, I think this is going to be the too high case, but I could have that backwards. And right here will be the too low case. And we'll call this too high case. Now for the too high case, we want to too high here. We're doing the too low case first, I guess. Too low. Load immediate extended. R8 and too low dot lower. And we want to call the print string with a new line after it. And for the 2 high case, and for that we can branch all the way around it. Not write code, we'll just do the same branch we're doing here, because it wasn't right. And for the 2 low case, or the 2 high case, we should fall to 2 high case. We'll come to 2 high case, and we'll print the other string. And instead of low, it's going to be high. We might have those messages backwards. We'll take a look and see. Probably do. Got a 50-50 chance of getting it right on a guess, but the compiling cycle is so quick here, as long as you remember to compile it, that it's quite easy to do. So we did assemble it that time, and we're getting very close to being able to try it out here. Let's see what happens. 60, 78, 80, 100. Start it up. And it's ready for us to exceed the number. It's a 51. Let's put in 88, which should be higher. And my number was too high. How about 50? My number was too low. So we got it right in our comparison. And if we do 51, we got it. So it looks like the program's up and running. All we got to do now is get rid of the printing of the answer and give it a shot here and see what happens. The printing of the answer is right up here. Let's see, we get the random number and then we print it out. So we just don't want to do that anymore. Save it. Don't forget to assemble. Those 2 windows sometimes look too much alike. Sometimes I click the wrong one. Processing, update memory, yes. Compile the FPGA. I might have pressed the button too early that time. Let's give it another shot just in case. And press a key. Well, we need to print an extra line after that any key to start message. Wait for key. We got that. After we got that, we want to print a new line, which I know there's one of them around here somewhere. That one will work. Just uncomment it when we get it up there. Now we have a new line, so we should make that clean next time we run. Let's guess 55. Too low. Let's guess AA. Too high. So it's somewhere between 55 and 2A. Let's try 88. Too high. So it's between 55 and 88. How about 75? 75 is too low, so it's between 55 and 75. How about 65? Too low, so it's between 65 and 75. How about 70? It's too high, so it's between 65 and 70. Remember, these are hex, so let's go for 68. 68 is too low, so it's between 68 and 70. So let's try 6C. It should be in the middle somewhere. So between 6C and 70, how about 6E? Too high, so that leaves 6D. And we got it. Pretty good. One thing it'd be nice to have is how many guesses it took, so you can compare the times that you run and how many shots it takes to do it. And if you want to be competitive with somebody, you can both try it and see if you get it quicker. Clearly a binary search would be start in the middle, and then it's off by that, and go to the middle of that, and it's off by that. And with 8 bits of values, you should be able to get it in, I don't know, I'm not great at math, but 128 tries? No, only 8 tries, because it would be each bit. You would know that it's more than 80, less than 80, that kind of thing. Let's go ahead and add the count in here for how many times you tried to do it before it ended. Well, we got plenty of registers available, so we're using R15 right now for the answer. So let's just use some other value here. Let's use load immediate extended. R14, we'll use that as our count, and we'll load it with 0 to begin with. That should work for an immediate value. After we guessed it not right, we want to increment that counter. We could just increment the counter every single time. It doesn't really matter. So after we get the random number, we're doing it. We can do it probably right here, because that's actually the loop. It's not right, but it's just a loop. So add immediate, R14, R14, and 1. So we have a counter now that does the counting of how many times we got it right. And at the end we want to print that. So let's see, all the way down here, you got it right and it printed it, and we'll go down and copy this. Well, no, we'll just print out the number. The number we'll do, it's print long, I believe. Let's see, we'll probably stop it up here somewhere. Yeah, we can just steal this routine. Print long. Okay, and we have to put that thing we want to print in D8. So we want to put, we'll do an add immediate, get it in there. We'll put it in R8. I want to take R14 and add 0 to it. And I have to learn how to type. That should get us pretty close. And we want to say how many guesses it took. Let's see, number of guesses. Well, that was a good name for a variable, wasn't it? So we want to print that up here before we print the long. And we can do that right here. And we probably want a new line after that. And we want to load immediate extended, R8 with the number of guesses. And we want to make that the lower. And then we want to print that string in a new line. So hopefully we'll get this right. So we're adding to R8. So that should take 0, add it to R14 and put it in R8, and then that'll call up the print. And we have a new line at the end. So I think that should be pretty clean. Let's give that a shot and see how well it works. Might be pretty close at this point to having a decent program. Okay, compiled without a problem, or assembled I should say. Keep saying that wrong. Update the memory, yes. Compile the FPGA. And upload it. And let's see what we got. So we'll seed off our random number, and we got the line feed there, which is good. Let's do the binary search. Go for 80. 80 is too high. Let's go for 40. 40 is too low. Let's go for 60. 60 is too high. Let's go for 50. 50 is too high. Let's go for 48. 48 is too high. Let's go for 44. Somewhere between 44 and 48. We'll try for 46. It's too high, so it has to be 45. And we got it on 8 tries. We're not printing how many tries it was there, but we can add that. Not quite sure why. I thought we told you that. Well, we created it, but we didn't tell it to print. So let's go ahead and tell it to print that string. And see if that works. We're so close to having a pretty decent little program that we would have been proud of in BASIC back in the day. And the magic of the random number generator from back in that day was some computer scientist's responsibility, but in this case we used our timer to do the random number generator, and because we let the user pick the time to select the random number generator, it turns out to be pretty darn random, really. And select start, and it's assembled, and let's hit any key to get a random number. Try the same binary search. 80, too high. 40, too high. 20, too low. 30, too high, 28, too low, too C, too high, too A, too high, too 9. And we got it in 8 guesses. We don't need that extra carriage turn after the number of guesses. Number of guesses, we don't need that. And maybe this is the final tweaking and polishing of the program. Maybe. Hopefully it'll work. Try it again. Update memory initialization, and I want to keep the changes. And tell it to compile the FPGA. Get ready on the trigger to download here. As soon as we see that 100%, we got it. And let's go and run again. So hit a key, guess a number, we'll do the binary search or the halfway search. Too low, C0, too high, A0, B0, B8, B8 through C0, so BC, BA, B9. Yeah, we got an 8 tries. So again, we've done. We didn't get lucky on any of these. All tries have been 8, which is, I believe, the number of bits involved here. But let's count, make sure we got that right. 1, 2, 3, 4, 5, 6, 7, 8. So yeah, it's printing the right message out, and it was 8 tries. I don't think it could be any better unless you guessed the number. Could be worse if you didn't do the halfway search, which we're doing. But there you go. Up and running and pretty smooth. Same result out on the VGA screen. I don't have a VGA capture card, so you'll just have to take my word for it at the moment. And actually a little bit different. It doesn't have the extra line feed that we have here on this display, so we could probably fix that. It's kind of unnecessary. Thanks for watching. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindy where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.